Okay, well, Tony, let's bring you on stage and we'll give you a proper introduction. So everybody, Tony Alicea, he's going to give a presentation that he's calling Processing Usability Feedback. So this will be a great one, but I have to share who he is. We're very fortunate to have him. He has over 25 years of experience in software engineering, but as a database designer and as a technical educator. And you may recognize his name because he does have several courses out on Udemy and Pluralsight, and then Don't Imitate Understand.com, which I believe is your own platform, right, Tony?
Yeah.
Okay. Yeah, so I highly recommend you go find his courses, though. You may have already heard of him because he has a very popular course. It's called JavaScript Understanding the Weird Parts, which was how I originally learned who you are. But love that course. And it's always just so much fun to watch. You're not boring. Sometimes software engineering tutorials can just get so robotic, and Tony is not robotic. So he brings in a lot of life and personality, and it's made him a top selling course instructor on those platforms. But earlier I mentioned he is also currently the director of education at his company, which is the Smith Group. So education is just part of his core. And I love this fact. He has taught over 350,000 students on those platforms. So pretty impressive stuff. But yeah, thank you, Tony. We're really excited to have you. But I'm going to ask you the same question now. As a a best-selling author and someone who's taught that many students, what does it mean to you to be a quality software engineer or programmer?
Yeah, I was thinking about this question too, like Jordan, it's an interesting question. And where I came out with it is that being a high quality engineer, programmer is about being a good communicator. Uh, and what I mean by that is all the aspects of what we do could be considered forms of communication. When we write code, it's communication to ourselves in the future and anyone else who will read that code in the future, and communication to the system to tell it what we want it to do. And then the actual, if we're writing front ends, the actual user interface is communication to the user to tell them whether or how they can accomplish the thing they want to accomplish and all the messages that go along on for every click that they do. So I think high quality means that you have clear and accurate communication in all of those channels of software development.
Like that. And thank you. It is, like Jordan said, it's a loaded question, but it's, I think, fun to think about. So I appreciate it. Really good thoughts. So, but yeah, with that, I'll just turn it over to you and let you share.
Thank you so much. And thank you for that nice introduction. Well, I already had a lovely introduction. Thank you so much. I'm Tony Alicea. Um, I've been a dev and a user experience designer for 25 years. You can find more about my courses, links to my social media, other things on tonyalicea.dev. I'm also the director of education for a company called the Smythe Group, SMYTH, that is both a dev shop and does dev to dev advisory services. So you can check out both of those sites. But today, we're going to talk about processing usability feedback. And I've spent a lot of years doing both development and user experience design. And so when we talked about quality for this session today, we also know the importance of building high quality software is making sure that the software is usable, that the user can accomplish what they need to accomplish, that they can do so easily, that they want to use the software. So how can we take the feedback that we get and then decide what updates are needed to be made to improve the quality of our software? That's the question we're going to try to answer today. So what we're going to do is talk about first usability testing and user observation. That's our first area. And whether you are doing something formal, like formal usability testing, or you're just watching people try to use the software that you are making, what do we do with the results of what we see as people are trying to use our software? Or maybe it's even some kind of analytics that we're trying to analyze to understand how people are using the software. Well, the thing that concerns us the most when it comes to quality is if there's confusion or frustration. So maybe for example, in a formal setting of usability testing or watching someone use the software, you see them look something like this. At some moment in the software, there's this point of confusion. They don't really know what they're supposed to do. They're not sure that they understand what's happening in the software. To understand how to process that moment, we need first to have a framework to work off of. What we're going to call it is a mental model. A mental model is how we think something works. And in the case of usability, we deal with cognitive models. It's how we think someone thinks. So when someone sits down and uses a piece of software on the computer, on their phone, what's happening with every click or tap or swipe? What's going on in their brains? Well, we don't know 100% for sure, but we have models that seem to show us what's happening, and that can help us make good choices. Now, a model that's been around for a very long time, originally started back when people were using ATMs, and that was a newer technology, and it's still proven true today, is something called COLIDES, Comprehension-Based Linked Model of Deliberate Search. And that's something you can Google it. And this model proposes that when people are using software, they go through this particular sequence every time they do something, every button click, every swipe, every time the screen changes or updates. So what are they going through? Well, we'll use google.com as an example. Someone comes to google.com and let's imagine they've never been there before. So they form a goal in their minds. There's a reason why someone is using the software or the website or the app, whatever it is that they are to accomplish. So let's say that they want pictures of zebras. That's their goal. They've never used Google before. So what's the cognitive model we have for how they process the screen in front of them? Well, the first thing in our model is that they segment the page. Whatever UI they're looking at, they actually begin to segment it into sections. And that segmentation then takes us to the next step. They then isolate a section of the page and they begin to hunt for something that they think will help them accomplish that goal that they have. We often call this information scent, kind of like a dog trying to find something on the ground. It's hunting. So if they're thinking, I want to find zebra pictures, they might be looking for the word images or pictures or find or search. And so as they focus in on a section, and this can all happen very, very quickly as they move from section to section, words that we choose on the page may then draw their attention and they begin to make the assumption, what do I need to do to accomplish my goal? They make an assumption and then they take an action and see if they get closer. So in this case, they might see Google search. The word search suggests find. It's close to that text box. So perhaps they'll try typing in pictures of zebras or zebras and hit that button. They make an assumption and then they take an action. But when there's usability problems, that usually means somewhere along the line, that cyclical process of every time they're taking an action or processing the response on the screen, something went wrong. For example, let's suppose that the button didn't say Google search. Let's say it said run algorithm. That's technically an accurate term. But would it connect with the goal and the words that the person thinks of with their goal of finding pictures of zebras? No. So they might sit there and look and try to figure out what to do. And there's a long pause and they have that look. And you go, why? The button's right there. Well, because we have a usability problem. In this case, it's information architecture. And that's one of the big common usability problems, that the words that we have on the screen, the choices that we've made about how we present the information doesn't match the words and the kind of information, the assumptions that the person has in their head. The user is very different from the developer. The developer knows things that the user doesn't. So we should be presenting information that the user knows and is familiar with. There's another possible problem that's also very common. For example, when they're hunting and segmenting the page, sometimes we have a problem with something called our Gestalt principles, which is how and where we organize things physically on the screen. And so assuming someone is consuming the information visually as opposed to a screen reader, this can have a massive impact. For example, let's suppose I put a lot of space between that text box and the buttons. Well, now it's no longer clear that the buttons are related to the text box. When the user segments the page, they may segment the buttons differently and think, well, I'm going to click that because it'll take me somewhere to search. And they never type in the box. In fact, usability testing has shown that information architecture and Gestalt principles, these are probably the two biggest, most common kinds of usability problems. And if we make adjustments, we can get better results. But how do we know what adjustments to make? When we process these results, we want to remove variables. What can happen when we see that something is difficult to use, users aren't happy, is we kind of throw it all out. We say, we have to start from scratch. We need to redesign this. And that's a very bad way to get to good usability. Instead, we want to isolate the moment in that cycle of segment, and then they pick a segment, and then they hunt for information to then assume and act. We want to isolate the moment when that cyclical cognitive process, where in that process something went wrong. The moment that they were here on this page, something went wrong, isolate that moment, and then make the smallest change possible because we're removing variables. If you make many changes, you may solve one usability problem and introduce another. Figuring out the usability of your software is in many ways a scientific process. We have a hypothesis. I think this software is easy to use. And then we test the hypothesis, whether it's releasing to users or running usability tests, and we see if the hypothesis is true. If we find that the hypothesis is wrong, it is not easy to use, then we want to isolate the possible variables that are causing it to not be easy to use and only change one thing, try again, and see if now it is easy to use. But if we make too many changes, you can't isolate what's really wrong. In this case, I would just move the buttons and see if users find that to be easier. And that would be the only change to make. And if there's still problems, now you can isolate again. Changing one variable at a time, you get faster usability improvements without side effects. Now let's go on to our second area that we're going to talk about for processing feature requests, usability problems, high quality software is what we're going for. After you release software, you inevitably get feature requests. And that tends to then suggest, oh, we need to improve the software. There's a problem with the quality. But how can we know what to do when we get all these feature requests? How can we know what to invest in, where to put our dev team time? Well, again, we get a feature request. The user is asking, please, I need this. And so we can feel like that's urgent. We need to do it. But is that the case? I like to use an illustration. Let's suppose your neighbor knocks on your door and says, I want a hammer. Can I borrow one? What should you say? That's a feature request. I don't have a hammer. I need one. What we should do as development teams is ask, why? Our neighbor then says, oh, well, I'm building shelves. Interesting. Why? Oh, well, I'm buying a lot of reference books. Oh, why? Well, you see, my computer keeps crashing and I can't trust it anymore. So I'm just going to buy a lot of books. So I need some shelves. So I need a hammer. See the problem? The hammer, the needing books, and the broken computer. The hammer is a feature request. The I need books is their solution to the problem. The real problem, the actual problem, is the broken computer. People tend to express their solutions to their problems, not the problems themselves. And the feature request is often a clue as to what their solution is, and their solution is a clue as to the actual problem. Where should we live as developers? In the feature requests? No, what we should actually care about to improve the quality of our software is the actual problems that users are unable to solve or unable to discover as a solution. That's where we should be coding. So how can we do that? Well, first we have to accept a truth. Most users are not software designers or engineers. But when we just take their feature requests and look at it as requirements to be implemented, we're treating them as if they are software designers or engineers. Users know their problems better than us. That's just true. But we know the solutions better than them. And that's okay. That's not disrespectful of the user. We're doing our job. So connecting feature request to solution is about asking why. And connecting solution to problem is about continuing to ask why. Dig down and research why. Think it through or interview users and try to find out. That way we're living here. We get to an actual problem, and then we as a development team work on good solutions. And a good solution oftentimes can be a simple solution, something fast, inexpensive, easy to maintain, etc. And then, of course, you can test it, which we talked about before. So again, feature requests are clues, not solutions, to the real problems in your software. If you want high quality software, don't keep adding features according to requests. Figure out the problems and then solve those problems. Feature requests, a lot of dev teams, they'll automatically turn feature requests into tickets, but tickets for implementation and tickets to be estimated. But really, feature requests should be tickets to research, to ask those why questions and to try to figure out the proper solution. Because what often happens is you may have many feature requests and you do the why and you get to a couple of, oh, the users, this is their solution to some problem. And then when you why down those solutions, oftentimes you get down to a single problem that multiple feature requests are trying to solve. I'll give you a real world example. Suppose you have some software, and this has happened. I've seen this happen. You have some software that has some data, a form with or a report page with a lot of information on it. And so we get some feature requests. I need to download a report of this data. But you get a different feature request. I need a copy button to copy this data into my clipboard so I can paste that somewhere else. And you get another feature request. I need an email button that lets me pick people to email this to, and then we'll send this information to them. And so now your dev team is going, oh, we're going to have to add email functionality, and how much is that going to cost? First, if we why down the problem, we realize that the solution is I need the data. The users, all of these users think I need the data. Give me the data. That will solve my problem. What's the problem? They need to share the data. They're trying to email it or print it or some other way share the data. So what's the solution? A solution could be build a share button. Make a way for the URL to be shared. And if the person has access to the data, that they can just click it. And now they can copy that URL. They could paste it into an email. Whatever the case is, we've solved the problem. And because we've solved the problem, we've automatically solved all those feature requests. And so if we need to share the data, we build a share button. We're sticking with problem and solution. So where does this all get us? Between usability testing, feature requests, improving the quality of our software by processing this information. Well, if we make small changes and retest, and then when it comes to feature requests, we ask why, and solve the real problems, we'll end up with high quality, usable software that makes users happy to use it. We'll have success in producing that high quality software. And that's it. Again, I'm Tony Alicea. You can find me on tonyalicea.dev and the smythegroup.com, which helps with these kind of issues too, as far as analyzing your software for usability, security, and other things. And that's it. Thanks for having me.
Yeah. Do we have any questions for Tony?
I did have a question actually, real quick.
Yeah.
So I totally agree with you, by the way. You drill down to the why. My question is more around where is the right place for this to happen, right? As in, is it the responsibility of the engineers to work directly with the product managers to make sure that they're drilling down to the why, or should the engineers be talking more directly to customers, or how would have what is a good way to drill down further to the real why of that feature?
Yeah, that's a great question. It depends a little bit on the organization of your team, right? And the organization that you're in. Ultimately, you want to have someone connecting to the user. So if that's like a user experience team or product manager, or sometimes it's a help desk or whatever the case is, that is connected to the user to get that information. But then drilling down to the why, I find that it works best as a unit where every discipline is actually represented
Mhm.
in having that meeting. And the reason is because then you get the best possible solutions to the problem. Like
Mhm.
if you have DevOps and a dev and a UX and a requirements and a help desk representative, let's say all just sit around a table for 15 minutes on a feature request. Then what I find that happens is you start asking the whys, and as we ask the whys, you get different possible solutions to the problem. Where it's like, oh, UX says, and UI, the designers, they say, oh, well, we could move the button or change the button name. Oh, that would solve it. Or maybe the development team goes, oh, we can build a share button really easily because we can do that. Or the DevOps team says, etc. So I think the best way for it to happen is for it to be multidisciplinary
Mhm.
with people there that have direct contact with the users.
Yep, I agree with that. So essentially, what you're talking about is product trios, more or less, you could say. You could
Mhm.
boil that down to even further and say that the product trio needs to have ways to experiment and needs to have ways to directly talk to the users and dig further into the why.
Yeah, and sometimes the pushback on that in the dev team is that that's a lot of overhead,
Mhm.
but the balance of how much you save by getting to the why and then finding the simplest possible solution for the dev team to implement, it just
Yeah.
there's no question that the ROI is incredible.
How do you show that ROI or value to the dev team that may think it's a lot of overhead?
Yeah, that's good. It does take doing it a couple of times, to be honest. Um, but I think what I would typically have done is have some kind of like after action report
Mhm.
where we said like, here's how much. It depends on how you're charting your hours, right? Your development effort, but basically having something where we say, here's the development effort of what we thought we had to build or what was requested, and here's the development effort of what was done, and then also chart like when you say here's the development effort of what was requested, you can include all the feature requests together, right, cumulatively that would have been done, and then say this is what we did that solved the core problem and compare those hours, if you want to put it that way.
Okay. Yeah. And Jeff with a G in the chat had a good ad is that sometimes, it may not even be the stake or it may not even be the dev team that doesn't want to. It may be the stakeholders that uh maybe they see it as saving time for the
Yeah.
dev team. Like, hey, you guys should be in code. Why are you asking these questions? Kind of a mindset, right?
Yeah, so it is a cultural thing. I find that what needs to happen is that those who are interfacing with the stakeholder, anybody sitting between the dev team and the stakeholders, need to also have buy-in on the mindset that
Yep.
this is how we build software. And the comparison I make is if the stakeholder said, we're not allowed to do testing, which Jordan just talked about, right? What if they said, the stakeholder, and we don't have time for that. You can't write tests, just ship software. We would say, that's how we ship software, right? That's how we ship quality software. So we should treat these processes for good usability with the same professional dignity that we do these other processes that we do in code. It's not something that you can pick and choose like a fast food menu. This is how we build good software. And if everyone has buy-in to that, and that's from the get-go, from that initial client relationship building, that's understood, and it's just kind of like, well, no, this is what we do. This is how we do it. This is how you get good software. Then I find that's the best way to actually make that happen.
Any other questions? See, I like it because it takes that, it takes away like just you being a feature factory, right? Like,
Yep.
sit down, do your job. It makes you more thoughtful and like cognizant of what you're doing and why you're doing it. So
yeah, that's a good point. That's something I didn't talk about. I didn't really have time to get into, but it also lends itself to developer buy-in and ownership of a feature. And ownership of a feature generally results in higher quality software from devs, I find.
I had a question.
Yeah, John.
Kind of going back to what you were talking about. Oh, sorry, I heard echo. Going back to what you were talking about with like you come up with the solution and then you kind of evaluate and you see if it made a positive impact. How do you get the most accurate results? Because what I sometimes see is we say, oh, we released this on this such and such date, and then the graph goes down and less users interact with the button. And then it goes back up again and you didn't do anything. And it's just like this variance. And how do like effective teams able to get like some stable data so you can actually understand the trends related to the causal effect, causation versus correlation scenario and issue? That's kind of like the big thing that my team and I are trying to figure out,
Yeah, that's a great question. My answer to that, in my experience, is that analytics are very limited in how much information you can get about usability issues, simply because there are so many other variables that are unknown. So in any scientific endeavor, unknown variables limits what the conclusions that you can make, right? Because you don't know if the internet was down in the area where users were usually, using your software, whatever the case is, right? So introducing direct user observation and usability testing of a cross-section of users that you believe are representative is the best way to get at least something actionable. You suddenly realize that your average user is, this particular demographic. Find a few people, have them sit down and try it and watch them. And what I've found is that you can get to about 90% accuracy of what the usability problem is with less than 10 people if you have a good cross-section. And I've seen that to be true for like 20 years. You do not need like some kind of massive effort to test everyone out there. You just need a good cross-section. And what'll happen is you'll have like, out of let's say 7 people, one may have a problem with something that nobody else does. And another one has a problem that nobody else does. But 8 of them have the same problem. There's your issue. And kind of the law of statistics and averages works to your favor in that case. So I guess I would say, I don't know how helpful it is, but I would say that analytics is not as helpful as a small, well-represented group of users that you can actually watch try to use the software.
4, 3, 2, 1. Earth below us, drifting, falling, floating.